After central angles, we have inscribed angles. I'm going to do a different color on that. Inscribed Inscribed angles have their vertex on the edge of the circle. Can y'all see that green? That's kind of light. Let me zoom in a bit. Have their vertex on the edge, or circumference if you want to say that, on the edge of the circle. And the rays go to other parts of the edge. So on an example picture, here's your center. A lot of the time you'll see the center marked, even if it's not being used. So we're not going to use it because our vertex needs to be on the edge. Let's say it's going to be right there. And then your angle could go out like that. It might or might not pass through that center. Sometimes it will, sometimes it won't. But the two end points, the two rays of your angle, they're always going to come out here, and you're basically going to have 3 points on the circle. So a single inscribed angle will divide your circle into 3 different arcs. You see you have this one over here, you have this one over here, and you have this one over here where the angle opens. This one is the one that we are most concerned about. I don't have a whole lot of space left on this side. I don't have any actually. So I'm going to flip my paper. Well, I'm going to get a new sheet because if I flip it over, these pins will go through. So on my other sheet, we're going to continue talking about those inscribed angles. So the second thing that we need to talk about, I'm going to put inscribed continued. Second thing that we need to talk about is the inscribed angle is half the measure of the arc it makes. Inscribed angle is half the measure of the arc it makes. So once again, I'm going to draw us a little example over here. That's a terrible circle, but let's pretend. Okay, so if that in there is, we'll just give it a number. Let's say that that's about a 15-degree angle. Then this arc out here is going to be a 30-degree angle. Should have picked the darker green, sorry. If the angle is 20, the arc will be 40. If the angle is 50, the arc will be 100. You can go on forever like that. If it's a right angle, then it's going to be 180 degrees. It's going to cut your circle in half. We'll talk more about that later. But all inscribed angles are half of the arc that they subtend or they make. I guess I probably should tell you that word. Wherever it says like the arc it makes, let's put the word subtends. That just means that it creates that arc. And we could have said the same thing over on central angles. It's not specific for inscribed. The arc that it makes is the arc that it subtends, and that's going to be this arc in here. This is the subtended arc. Basically just the arc where the angle opens to. Exactly. Very good. So when central angles is what we're talking about, we talked about how you're going to set a lot of stuff equal. And as Asia just pointed out, these are going to have some stuff multiplied by 2 or possibly divided by 2. So we're going to put multiply and divide by 2 for solving. Let's draw us another circle. That one's a little bit better. Still looks kind of egg-shaped. We'll make kind of a wider angle this time. Obviously, your arc out here looks kind of like a little smiley face. Let's say in here that this is 4x plus 10. And then let's just keep it easy. Let's say this is 5x. I don't know how this is going to come out because I'm just kind of making these numbers up off the top of my head. So here's what you can do. You have 2 options because you can either take the smaller one and multiply it by 2, or you can take the larger one and cut it in half. Now, personally, I think students are generally more successful multiplying by 2 on those smaller numbers. And so I would recommend that you just pick one and do it every time. And I think the one you ought to try is probably multiplying by 2. So that would look like this. I take that 4x plus 10 and I put it in parentheses because that's one whole amount. And I need to multiply by 2 the whole amount, not just the 4, but the 4 and the 10. And that's going to be equal to the outside amount, 5x. Okay. So when you start solving that, you're going to distribute that 2, just like I have it drawn. It's going to be 8x plus 20. And then you'll subtract 8. This is not going to come out evenly. So you'll have 20 equals negative 3x. And you'll divide by negative 3. And so we're just going to leave this as negative 20 over 3 equals x, because that doesn't reduce and it's going to be a repeating decimal. Now, that's not the arc measure. So that would be okay. Actually, I probably should have reversed these 2 amounts. But either way, this part is what I wanted you to make sure you got. You multiply times 2 the whole amount, not just the 4, not just the 10, both of them, because both of them together make that angle. Now, the other way you could do it, I'm just going to draw a line. That's an O, by the way. Or the other way that you could do it is you could cut that 5x in half. You could say 4x plus 10 equals 5x divided by 2. And then watch what happens. The first thing you want to do is get rid of that fraction. So how do you undo divide by 2? Multiply by 2. So the whole side gets multiplied by 2, and this is exactly the same thing that we've got over here. You have 8x plus 10 equals 5x, and it already matches. So obviously they're going to be solved the same way. So either way you want to do it, it's totally fine. But just to reiterate, I think most students are more successful multiplying than dividing, especially when sometimes you have odd numbers that don't easily get divided by 2. So I think you should multiply the angle times 2 and set it equal to the arc. And if you want to do it the other way, that's fine as well. All right.